In today's video, we are going to be talking about 3.5 sketching cubic functions. Sketching cubic functions is a way for us to see what is happening with the graph by only sketching some of our key features. A real root or a real zero is an x-intercept, and we're going to be using those roots or x-intercepts to help us graph our functions. The number of turning points is always less than the degree, and a turning point is wherever we would have a relative maximum or minimum. In order for us to sketch our cubic functions, the first thing that we're going to have to do is we're going to have to factor our functions using some of those factoring skills that we worked on previously. Then we are going to have to solve each piece that we factored to find out where our x-intercepts are. After that, we will be able to identify where our y-intercept is potentially, what our degree is, and we can use our leading coefficient to tell us what the graph will look like. We are going to do a few different examples of these. Some of them we will have to factor on our own. Some of them will already be factored for us. Sketching cubic functions is an important skill to have because this allows us to see what is happening with our graph and get an idea of what a cubic function actually looks like. We are going to start off with number 1. When we see this cubic function, it's not in a factored form. In order for us to graph this on our own and get a sketch of it, we're going to need to go ahead and factor this equation. Anytime we're dealing with a cubic function, we always want to start by checking to see if there is a GCF that we can pull out. Sorry, let me get this to focus. Alright, so for this first one, I have f of x equals x cubed minus 4x. The first thing that I notice is x cubed and 4x both have an x. So I can go ahead and pull out an x from each term. So I pulled out a GCF of x. From there, x squared minus 4 is a difference of two squares, or a dots problem. So I can factor this. F of x equals the x stays out front, and x squared minus 4 factors to x squared plus 2 times, or x plus 2 times x minus 2. If you guys need a refresher on how to factor that, you can check out some of the factoring resources on Canvas. The next thing that we're going to do is we're going to set each individual piece equal to 0 so that we can find our roots or our x-intercepts. X equals 0, x plus 2 equals 0, and x minus 2 equals 0. This is really similar to what we did in your 3.2 notes. X equals 0 is already solved for us. Then I subtract 2 from each side in my second equation, which gives me x equals negative 2. And for my second equation, I will add 2 to each side, which gives me x equals 2. Now that I have my x-intercepts, I can sketch my graph by labeling each of my x-intercepts and putting my points on my graph. So my first x-intercept that we had was x equals 0, which is 0, 0. Next, I had negative 2, 0. And these don't have to be at exact points. You don't have to draw out all of your lines and things like that. As long as you label your points, we're good to go. And then we have 2, 0 as our final x-intercept. When I look at my leading coefficient, I notice that this is a positive function. We know that if a leading coefficient is positive, that the function will always rise on the right. So for our cubic, we'll start at the bottom and turn through our graph. Anytime I sketch a positive cubic function, I always think of Drake. Started at the bottom, now we're here. It's been a little bit of a roller coaster, but we still made it through. Looking at my graph, I turned the direction I was moving in twice because my pen went up, down, and up, and I hit all of those x-intercepts. We're going to do the same thing for number 2. The first thing that I notice about number 2 is it is a cubic and it is not in factored form. So I need to figure out what GCF I can pull out. As I look through these, I can pull a negative 2x out of all 3 pieces because all of these have at least a 2 and they all have at least one x. I'm pulling out a negative 2 because when possible we want to pull out a negative with our GCF just so we don't have to deal with a negative when we factor later. That is going to leave me with x squared minus 2x minus 3. And the reason these signs changed is because we pulled out a negative 2 instead of just a positive 2. I need to factor what I have left now that it's a quadratic. I'm going to use my x. Negative 3 is my last term, so it goes on top. Negative 2 is my middle term, so it goes on the bottom. The factors of negative 3 that can give me negative 2 are negative 3 and positive 1. Because negative 3 times 1 gives me negative 3, and negative 3 plus 1 gives me negative 2. Now that I have my factors, I'm going to go ahead and write out my function in its full factored form. So x minus 3, x plus 1. To finish and be able to sketch my cubic function, the first thing I need to do is solve for my roots or my x-intercepts. So negative 2x equals 0, x minus 3 equals 0, and x plus 1 equals 0. To solve my first equation, I'm going to divide each side by negative 2, so x equals 0. To solve my second equation, I'm going to add 3 to each side, so x equals 3. And for my third equation, I'm going to subtract 1 from each side, so x equals negative 1. Now that I have my x-intercepts, all I have to do to sketch my cubic function is plot my points and then decide which direction my arrows need to be in. I know I'm going to have a point at 0, 0. I know I'm going to have a point at 3, 0. And I also know that I'm going to have a point at negative 1, 0. Now that I have labeled my points, I need to go ahead and draw my line to sketch my cubic function. Because this has a degree of 3, I know that it's going to have 2 turning points, so it's going to change directions 2 times. I also notice that this has a negative 2 as the leading coefficient. This means that my function is going to start above and it's going to finish falling on the right. I'm going to start up high and move my way through my x-intercepts. Whenever it's negative, remember, if you have a negative attitude, your life is going to go downhill and you're going to end up falling at the end. We're going to take a second and pause to see if you guys have any questions about sketching cubic functions. Now that we've cleared up any questions, we're going to go ahead and move on to the back. On the back, we do have some practice problems that are at the bottom that I am going to have you guys do in just a little bit. But we are going to walk through 2 more where we are actually going to already have them factored for us. So we're going to look at number 3 and number 4 up at the top. For number 3, I see that this has already been factored for me. I have x squared plus 2, or x plus 2 squared times x minus 5. From our 3.2 notes, we know that every time that we see an x plus 2 squared, that means that we're going to have to write that root twice. So I have x plus 2 equals 0, x plus 2 equals 0, and x minus 5 equals 0. When I solve each of these, I'm going to start by subtracting 2 from each side, which gives me x equals negative 2. The same thing for the second equation, which gives me x equals negative 2. And finally, for the last one, I'm going to add 5 to each side, which gives me x equals 5. Now, I'm going to go ahead and sketch my cubic function. I'm sorry, there's a little bit less room here. I have a point at negative 2, 0. And I also have a point at 5, 0. This is very different from the ones that we've done before. With each of these, I only have 2 points. We know that this has a positive leading coefficient because there's nothing negative out front. So whenever we are doing a positive one, we start at the bottom and we rise up to the top. Anytime you have a root that pops up twice, that is what we refer to as a double root. So when we deal with a double root, we're going to start at the bottom, come up to touch the root, and then we go back down and rise up through the last one. Because remember on Friday last week when we talked about double roots, a double root, it bounces back. Because if two people try and go through the same opening, they're not going to fit. They're going to bounce back. We're going to do the same thing with number 4. I have negative 2x out front, and I divide each side by negative 2. So x equals 0. And then I have x minus 4 equals 0. And x minus 4 equals 0, because I have to write that twice since it's squared. To solve that, I'm going to add 4 to each side. So I have 0, 0. And I don't know why I used lines there instead of dots. And I have 4, 0. This has a negative leading coefficient. So that means I'm going to start up high and finish going down low and falling. I'm going to go through 0, 0 because it is a single root. But when I get to 4, I'm going to touch my root and come back down because that 4 is a double root. And since we have 2 roots there, we're not going to be able to break through it. It's like we've reinforced that root so it repels anything backwards from it. I want you guys to take the next few minutes to try the following 4 problems on your own. Pause the video, and once you're done, I'm going to show you guys the answers on the video. That way you can check your work. Once you've checked your work, I'll be able to answer any questions you guys may have about the problems, and we'll go from there. So pause your video now and try the next 4 practice problems. Real quick, I want you guys to actually skip over number 2. Don't worry about number 2. I don't like how the numbers are working with it, so we're going to skip over number 2. But here is an example of how to do problem number 1 if you guys would like to check that out. Remember, sometimes we are going to have to pull out a GCF and then factor so we can find our zeros. Once you guys have looked over number 1, pause it for 1 more second and try 3 and 4 on your own. Here are the answers for practice problems 3 and 4. On practice problem 3, we did have a double root. So remember, whenever we have a double root, or we could see that as a root with a multiplicity of 2, that means that it's going to bounce back up in the same direction that it was in. For number 4, we don't actually have to do anything with that negative 2 because there's no x attached to that -2. The only reason that -2 is there is to tell us that we do have a leading negative coefficient, and that allows us to know which direction to draw our graph in. Remember, if it's a leading negative coefficient, we start at the top and we finish at the bottom. Remember, negative attitudes, they'll eventually just bring you down. Positive attitudes will just take you back up where you need to go. Alright, if you guys have any questions about how to sketch cubic functions or about the end behavior that we talked about earlier today, please let me know. We will be taking a quiz on this information on Thursday.